Copper is recovered from sulfide ores. These ores are mined, then crushed to form a concentrate economical enough to be smelted. In the smelting process, ore is heated to break chemical bonds between copper and other impurities. In addition, a flux of silica rock is added, causing impurities to separate from the ore and rise to the surface. These impurities, known as slag, are tapped off and discarded. This process is repeated, resulting in the formation of a molten sulfide of copper and iron, known as matte. Matte contains up to 60% copper, but requires further purification. By forcing air through the matte, sulfur is oxidized, forming recoverable sulfur dioxide gas. This gas then is transferred to a separate purification plant for manufacturing into commercial-grade sulfuric acid. From an ore containing less than 1% pure copper, the purification process results in a material known as blister copper, which is 97% pure metal. To remove more impurities, additional steps are required. In a furnace called an anode vessel, a mixture of natural gas, carbon monoxide, and hydrogen is forced through the blister copper. This reduces the metal, leaving it nearly oxygen-free. The resulting 99% pure metal then is cast into anodes. The anodes are submerged in an electrolytic solution of dilute sulfuric acid and copper sulfate. These starter sheets, or cathodes, of refined ultrapure copper are interleaved with the anodes, carefully spaced to avoid short circuits. An electric current is applied, and copper ions are transferred through the electrolyte to the cathodes, where they are deposited as elemental copper. Valuable impurities in the anode, including gold and silver, sink to the bottom of the cell to be recovered later. In about 14 days, cathodes of 99.99% pure copper are removed. The element copper has an atomic weight of 29. An atom of copper has a nucleus of 29 protons surrounded by 29 electrons. 14 atoms bound together by sharing electrons form a unit cell, which has all the properties of the metal. Unit cells, joined by sharing atoms, form crystals which are packed together tightly. These copper crystals can be manipulated into various products. Copper is an excellent conductor of heat and electricity. Copper is ductile, capable of being drawn or stretched without breaking. Copper is so ductile that a single kilogram can be drawn down to a wire 350 kilometers long. In many ways, we have come to rely upon copper products. Copper can be alloyed with zinc to make brass, and with other metals to make more durable, castable, and corrosion-resistant products.